Hello everyone, welcome to the Introduction to Data Science series. This is session 6 on recommendation systems. What are recommendation systems? In our daily life, you must know of a friend who likes to eat spicy food or sweet food, and the exact food item to recommend to him or her comes to your mind immediately. Think about another person who likes to go to mountains or hill stations very often. And there comes and pops up an image of a place that you must have been recently or some time back, right? And you recommend that to him or her. So recommendations is something that we naturally do, and it is part of our daily life. In some of the more interesting scenarios in matchmaking also, there are a lot of recommendations which go here and there before a person finally decides whom he or she is going to spend their life with. So to keep it more formally, right, recommendations are a big part of businesses. Let's look at some examples. If you look at YouTube, right, the videos are large in number. There are millions of videos. Now, how do you see what you want to see when you go to YouTube? Do you search for each video, or does YouTube provide you with a curated list and playlist of videos that might be of interest to you? It's the latter. And how does YouTube do that? It has a very robust recommendation engine behind it. Similarly, if you go to Google Play Store, for example, in Google Play Store also there are lots of apps that are always being developed, and which ones are the most relevant to you, that Google Play Store knows how to recommend and what to recommend. So there again, recommendation systems come into place. If you go to Amazon, what items or products does a user want to purchase is recommended by Amazon. And then there are all types of content, like if you go to Netflix, if you go to Spotify, if you go to Amazon Prime Video and so on, what kind of movies might interest you? All of these platforms already are predicting that, and they show that on their home pages. So recommendation engines are rampant, right? And why are they so important? Because they lead to an increased click-through rate, increased conversion rate, and finally increased revenues, because you are being shown the content that is most relevant to you, right? And you're most likely to be engaged in it and probably purchase it for that matter. So that's one reason why recommendation engines are very important, right, for business. And another reason is also to expand the horizon of a user's experience. So for example, if you always see one kind of a movie, right? If you always see, say, comedy movies, right? The recommendation engine might also recommend to you something which is slightly related to comedy, but it's not exactly comedy genre, right? So it might increase your purview of what you're watching, and it might interest you, and you might start watching that new genre then, right? So there is also a perspective of increasing your horizon, right? Basically discover new items, right, as I mentioned here. So these are the two main reasons why recommendation engines are very important for a business to grow, and that's why they are developed and used widely. All right. Now moving on to the key terminology behind recommendation systems. The first one is a query. A query is nothing but information about a particular user and any other contextual information about him or her. For example, geographical location, the device that was used to access the website or the app, and so on. So this is the query which comes into a recommendation system, and then the recommendation system outputs a document or an item, which is the exact item that it needs to predict that a user will like, right? So for example, if I'm going to Netflix, the product that I will get is a movie. So the item or document in this case will be a movie. So this is the second terminology which is required for understanding a recommendation system. And the third one that we use is called embedding, right? Now embedding is a more technical term. What embedding means is that each user and item is basically embedded into an n-dimensional space, right? From an even larger dimensional space. Okay, let me break this down. if you had 1000 users, right, and if say you had 10,000 items, you would, when you're representing all of these in certain vectors, or if you're representing them mathematically, the size of the vector will be very large because the number of users and items is very large, right? When you project these and create an embedding into a low dimensional space, what you do is basically for each user and each item for that matter, you basically have a d length vector, and basically have projected what initially you had for that user or item into a low dimensional space of length t, right? So that's called an embedding. And how do you embed a user into a particular embedding vector or an embedding space? You can do hand engineering, or you can learn the embedding through machine learning, right? Which is something which we will look at later. So there are three main key terms. The one is query, or also context. The second one is item or document, which is the thing that we are trying to predict. And the third one is called embedding, right? Where a user or an item are basically translated into a low dimensional space called the embedding space. Alright, now let's move on to the main types of recommendation systems. There are two main types of recommendation systems. The first one is content-based filtering, which, as the name suggests, is a recommendation system based on the content itself. And the second one is called collaborative filtering, which, as the name also suggests, is based on similarities between the users and their preferences. Now let's look at content-based filtering. In content-based filtering, the similarity is obtained between a set of items, right? Let me put that down more simply. If I like a particular item, right? Say if I always like blue colored items, or let's say I like a blue bag, I like a blue pen, I have purchased a blue bean bag, and so on, right? Now my items, basically whatever I have purchased, will be compared to other items which are there in the catalog, and all the other items will be evaluated for how similar they are to the ones that I have bought. And the items that come out to be the most similar, those items are then recommended to me. So the content is matched, and whichever content is most similar to a user's purchase history or preference history is then recommended to the user. That's what you can see in this particular chart, in this particular diagram. This is a user and he has already purchased or denoted his preference for item 1. Now what the algorithm, the filtering algorithm does is it calculates the similarity with all the other items which are there in the catalog, and that item which is most similar, then it is recommended to the user, which is item 2 in this case. Now let's look at how this would happen mathematically. For example, we are looking at movies, right? And let's say we have looked at 3 movies, Dark Knight, Fukre and Bahubali 2, which are some of the good movies of both Hollywood and Bollywood. And we have a user 1 for whom we are trying to predict what movie should we recommend him or her, right? Now we know that Dark Knight has a particular set of features, right? We have denoted that as x1, x2 till xn, and we have said that Dark Knight has the feature x1. This is a binary feature, 0 or 1, so it has something called x1. Now x1 can be, say, a thrill element, a comedy element, a suspense, a twist, anything, right? Let's assume it is a thriller element, right? So the Dark Knight has a thrill element. Fukre, for example, has, say, a comedy element. Bahubali probably has, a fantasy element to it, and we can also say, we can say it has a fantasy element. It has these 2 elements, basically x2 and xn. And the user 1, we are also denoting the user's vector in the same space as the items or the products, right? So user 1 is also denoted in this space, which in this case he has x1 and x2, which is the item of thrill and comedy. right? That we have talked about. Now think of each of these as vectors. So dark night is a vector of n length, right? x1, x2 till xn. Here it only has one for the first row and 0 otherwise, right? Similarly, Fukre has only one in its vector and rest are all zeros. Bahubali has two ones and rest are all zeros in this vector, and user 1 has two ones and rest are all zeros. So these are the vectors v1, v2, v3 and v4, right? Vector is nothing but it's a one-dimensional matrix, right? Yeah. Okay. If you are here with me so far, then what essentially we want to recommend to user 1 is that movie which is most similar to his or her preferences. That is this vector of the user, which movie is the most similar to this vector. So we will want to calculate the similarity between this user and each of these movies. So user 1 and Bahubali 2, what is the similarity? User 1 and Fukre, what is the similarity? And user 1 and Dark Knight, what is the similarity? And the similarity which is the maximum for a movie, we will pick that movie up and recommend that to user 1, right? So this is something called a content-based filtering. The similarity metric can be a cosine similarity and so on. There are multiple similarity metrics, but we will not go into the depth of each right now. So this is how content-based filtering works. But what are the advantages and disadvantages of it? The advantage of it is there is detailed knowledge about each of the movies which we can hand engineer, right? If there is some information that we know about the products or the items, we can include that as well into our analysis and our algorithm, right? Another advantage is that basically it looks at a user's history and it is specifically geared to a user, right? So if the user likes some very niche items, the algorithm can go ahead and predict very well other niche items that the user might be interested in. Now, one of the disadvantages is that the user might be limited to his or her preferences, right? And might not get the opportunity to expand their preference set, right? Because the algorithm is not looking at other similar users or what other items are there in the market, right? That this user would be interested in. It is looking at what he or she already likes and then is recommending something based on that. So that's a disadvantage. So this is content-based filtering, right? Which basically, to recap, looks at how similar the items are to the item that a user has purchased historically and then recommends the most similar item to that user. So it's basically doing content-based filtering. Now let's come to collaborative filtering. Collaborative filtering is a very powerful algorithm which looks at similarity between users' preferences and how alike are they in their preferences, and depending on a particular user's preferences, right, it then recommends that the item that a particular user has purchased to another user who is similar to that user. Let's break it down very simply. Let's say there are two users, right? Say Adam and Melissa, okay? And Adam and Melissa both have purchased a certain set of items, right? So we have identified that they are both similar. The recommendation that we want to do is for Adam, right? So we have identified Melissa based on her purchase history, and we have said that Melissa is similar to Adam, so let's consider her for the filtering algorithm. Once we have done that, what we do is we see that Adam has not looked at item 20 and Melissa has looked at item 20, right? Has purchased or probably used up item 20, and this is the item which would make sense to predict to Adam. So what we do is item 20 is then recommended to Adam, right? based on Melissa's purchase history or preference history, because Melissa is very similar to Adam. So this is how collaborative filtering works. And how does it work mathematically? How do we actually implement it, right? So for a certain set of users and a certain set of items, we create a matrix. For example, for users 1 to n, we know here, let's say the items are movies. So we know that user 1 has rated very highly these movies, right? These 3 movies. User 2 has rated another set of 3 movies, and so on till user n, right? And now we want to basically understand what should we predict to user 1? What should we recommend to user 1? How we go about this is a matrix, right? Let's say the dimension or the number of columns is m. We know that the number of rows is n. So this is an n cross m matrix, right? What we do is we decompose the matrix. We do matrix factorization, and we can also do weighted matrix factorization, right? This is a sparse matrix. So what we do is we basically find 2 other matrices, which when we take a product of, it creates this particular matrix. Basically, you take different combinations of u and v, you multiply them, you see that how close are they to the original feedback matrix, right? You calculate the error in that. It can be a MSE, mean squared error, root mean squared error, RMSE, and then you find those which create the closest matrix to the original feedback matrix, right? Once you do that, then you simply multiply UV transpose, you get another matrix which is not sparse, which has a lot of elements, right? And all of them basically correspond to certain ratings that you have modeled for. So for user 1, for example, we then pick a rating which is maximum and which is not part of the set that he or she has already seen or used. So that would be our recommendation to that particular user. Now behind the scenes, what it is doing, it is calculating the similarity between the users. It is also taking the information about the different items, and when it is doing the factorization, it is basically condensing all of that information into 2 different vectors, users and item vectors, and recreating the feedback matrix. We get a set of ratings, right, with the additional information, and then we capture that particular movie which has the highest rating for a user that he or she has not already watched. So this is how collaborative filtering works. To recap, collaborative filtering basically looks at similarity between users, right, and items as well, and recommends to a particular user based on another similar user's history. Alright, so far we have talked about the main types of recommendation systems and the key terminology involved and why we should do it and where all we can see recommendation systems. Now let's talk about the workflow of recommendation systems. The first step in building a recommendation system is candidate generation. What do we mean by a candidate? A candidate is any possible recommendation, right, which we can actually give to a particular user, right? So that's a candidate. And how do we generate certain candidates? We see that we can use content-based filtering to generate a candidate. We can use collaborative filtering to generate another candidate, right? We can also look at trending items, the most recent items which are there in the market, which are trending. We can recommend even those to a particular user. So imagine if you go to Amazon and it has Amazon Day sale going on, the item which has, say, the most discount would come up on your homepage, even if it is something that you probably have not purchased in the past and you probably are not that much interested in. It will still come up because it is a trending item, right? So that is a candidate generation. That is the first step, also known as retrieval. Okay. The second step is scoring, where you score each of these candidates depending on certain metric that you want to optimize for. So for example, if you want to maximize the click-through rate for a particular product on Amazon's online store, right, you would score each of these candidates on the click-through rate and pick that one which has the highest click-through rate, right? So that would be a kind of a scoring model that you would use if your goal was to maximize the click-through rate. If your goal was to maximize the watch time, you would recommend something else for a particular movie or a video. Probably something which is similar to what a user has watched, but slightly different so that it intrigues the user, right? So that would be another kind of a scoring metric that you would use. Why don't we simply use, say in the case of content-based filtering, we get a similarity metric, right? Why don't we just use that similarity metric as is? Why go to the length of, scoring and getting another metric to actually say how good a candidate is? The reason behind that is we are getting different kinds of candidates. The one is from content-based filtering, another is from collaborative filtering, another is from trending items, another may be from geographical location and proximity, right, to a particular product or a particular warehouse and so on. So all of these candidates were not chosen based on similar metrics. So similarity measure for this might be different from the rating measure for the collaborative filtering matrix, right? So that's why we want a uniform scoring model which scores each of these candidates on very similarly, right? And then it gets the final score for each of these candidates. And then what we do is the output of scoring, right? A subset of the top models or top candidates that we are looked at, not models, candidates, go to re-ranking, right? Where in re-ranking, we assess it a bit more subjectively. We look at whether the user has, already purchased that item, or a user has disliked certain similar items, so we should not recommend to him, or is it discriminatory to recommend a particular item to a particular user, say, who falls within a certain ethnicity, or it is a particular time of the year where we should not recommend certain items to certain users, right? For example, certain food items, right? And so on. So we need to prioritize whatever we have generated in terms of recommendations, right? It can also be prioritized in terms of freshness, right? How, when was the item introduced and so on. And then finally recommend. So this is what the re-ranking algorithm does. It takes care of the freshness, it takes care of the diversity. Are we recommending new things to a user or the same old things, and so on, right? So these are the three main steps in the workflow for a recommendation engine. So far, we have talked about the main types of recommendation systems, the workflow and the terminology. And this is pretty much that you need to know to go about understanding recommendation systems in detail. If you're interested even more, you can look at something called neural collaborative filtering, which I'm pretty interested in. Alright, hope you like this video. Let me know if you have any questions in the comments, and don't forget to follow me on LinkedIn and Instagram, the links of which are mentioned in the description below. Thank you for watching.